Are Euclidean geometry axioms always consistent? Imagine building a house on a shaky foundation. That's what it would be like if the basic rules of Euclidean geometry could lead to contradictions. But do they? Let's find out. Euclidean geometry is based on a set of simple assumptions called axioms or postulates. These are like the rules of a game that tell us how points, lines, and shapes behave. The question is whether these rules are always reliable or if they can sometimes clash with each other. Most mathematicians agree that the axioms of Euclidean geometry are consistent. That means no matter how you use them, they don't lead to any logical contradictions. To prove this, mathematicians often translate geometric ideas into algebraic systems, like coordinate geometry. Since algebraic systems are well understood and proven to be consistent, this translation shows that Euclidean geometry's axioms are also consistent. But it's important to remember that the original Euclidean axioms, created by the mathematician Euclid many centuries ago, weren't as precise as modern standards requiring. Some assumptions were left implicit or were a little vague. Over time, mathematicians refined these axioms into more formal systems, like those developed by David Hilbert and Alfred Tarski. These modern versions are carefully checked and proven to be both consistent and complete in certain ways. Now, the idea of consistency depends on the logical framework we use. For example, Euclidean geometry differs from non-Euclidean geometries, like hyperbolic geometry, mainly because of the parallel postulate. Both types of geometry are consistent within their own rules, but they describe different kinds of spaces. This shows that changing one axiom can lead to a different, yet still consistent, system. In everyday terms, the fact that Euclidean axioms are consistent means we can confidently use them to study shapes, angles, triangles, circles, and polygons in flat spaces. This is the geometry we learn first because it matches our everyday experience and is the basis for engineering, architecture, and computer graphics. To sum up, Euclidean geometry's axioms are considered consistent because they don't produce contradictions when properly formulated. Modern proofs relying on translating geometric ideas into algebraic systems, which are well understood. The original axioms were less formal, but today's versions are clear and reliable. Different geometries show that changing one axiom can create new, consistent systems that describe different kinds of spaces. This consistency makes Euclidean geometry a trusted foundation for understanding the world of shapes and figures.